All right. Our next speaker is a front-end engineer at SendGrid and is here to show us about all the fun things that you can do with the Web Audio API. Everybody make some noise for Steve Kinney.
Hello. This has already been covered, but my name is Steve. This is my Twitter, my handle. Is it a handle? Please follow me. It's very important for my ego. And also covered is I am a front-end engineer at SendGrid, where I take, they have this API that sends like 1 billion emails on like Black Friday. I get all of them. But they're also building this very like rich user interface in React with like drag and drop to like build these emails and like automation and all that fun stuff. So I get to like live in a world of using like super like modern web technologies to build HTML tables. And it's really great. And you should come do it with me. I'm also the organizer of DinosaurJS, which is a very similar feel and scope of a conference in Denver, Colorado every June. So you should come visit me. All right, so we're going to talk about making music in the browser. And there are some caveats. One is that this is not going to be a talk that is set to show you that I'm very smart, which is true. My mother has told me. But to show you basically that this is something that you can probably do. So we're not going to start at the mind-blowing, there are many really great talks that you could see about that. We're actually going to start things that you could probably go home and do tonight if you got super excited about it. So a big, this entire talk can be embodied in one very important meme, which is I am a tiny potato and I believe in you, you can do the thing, right? So this will be deliberately simple examples that you can try out. And all of the code is available, as well as links to all the different demos. So if you don't have to take pictures of the slides. You can take pictures of the slides, but you don't have to feel stressed about it. All the code is available, along with all the demos. So it's all on GitHub. Super cool. All right. I don't know how to break this to you, so I'm just going to say it. When you were busy building important websites for work, somebody put a synthesizer inside of your web browser. I'm not totally sure when it happened, but it's there. You just have to believe me. And it goes, this very cool little tool goes by the very regular name, the Web Audio API. And so what we're going to do today is we're going to learn how to use said Web Audio API to make some fun little experiments. So working with the Web API all starts with this context. Right? We do everything in the same way that when you're doing something with HTML5 canvas, you have a context that you draw on. Well, think about that you're painting with sound in this case. So we need to go ahead and create an audio context. And in Firefox and Chrome and all of those fun browsers, you can just do new audio context. In Safari, you need to do WebKit audio context to the point where I almost didn't believe that was still a thing, and I definitely verified it before this talk. Vendor prefixes. They're the best. We can say if audio context exists, use it. Otherwise, let's go ahead and grab the WebKit audio context. Just give me one of these. I don't really care. I just want to make some sound, please. So we'll go ahead, and the first thing we need to do is in our canvas of sound, we need some way to make it come out of the computer. Right? That's step one. Step two is have a thing that comes out of the sound of a computer. And so before I was a mediocre software engineer, I was a less than mediocre musician. So it works, the way I like to think about it is a signal chain on a guitar, right? Or in this case, a Keytar. Because when you look for guitar icons and you find a Keytar icon, there's no going back. Right? So we take a Keytar, we plug it into the various different signal chain, distortion pedals, or whatever, and it comes out the audio, the destination of the context, which in this case is, you can think about it like a guitar amp. So let's start with that. How do we get one of these destinations for our sound? So first, we go ahead and we create that new context that we saw on the previous slide. Cool. Then it actually has a property on it called destination. And that hooks into the operating system's magic where it makes sound come out of your computer. I am not a systems programmer. I don't know. Next thing we need to do is we need our Keytar, right? And there's lots of different sound sources that you can work with in the Web Audio API. You could work with sound files that you load. So if you wanted to make like a soundboard or something along those lines, that would work. You can take user input from the microphone. That'll do the trick. Or you can actually like make sound waves. For our purposes, we're going to do that. We're going to, this isn't a talk on playing audio with the Web Audio API. This is a talk about making music. So we're going to take this idea of an oscillator and use that to power all of our little experiments today. According to Wikipedia, this is how an oscillator works, is it makes a sound wave. The properties of that wave give it different characteristics. The wavelength, the further apart that gets, the lower the sound goes. The higher, I can't go higher pitched than this, so just imagine that I took in some helium. So as that wave gets tighter, we get a higher and a higher pitch. We'll talk a little bit more of like the nuances of that in a little bit. Then the amplitude is effectively how loud it is. Okay, so when we want to make the destination, that place where we can pump our sound to, we did context.destination. So I wonder how we might go about creating an oscillator. All right, context.create oscillator. This is going swimmingly so far. So now we have something that can make sound, and we have some way for sound to come out of our computer, but we're not all the way there yet. Belaboring this guitar/Keytar metaphor, we need to take a cable and plug the guitar into the amplifier, otherwise we're missing the point of the entire thing. So what we need to do is take the oscillator, and we need to connect it to the destination. You'll be shocked to learn the syntax for that. Basically, we take the oscillator and we connect it to the destination. Everything is great. Still not good enough. Yes, you've plugged the guitar in. Neat. Next thing you need to do is actually start making some sound. Does anyone we can do an audience participation thing. Anyone want to venture the name of the method to start playing a sound? Start. All right. So we'll go ahead and we'll say start. And you could just say start. And what will happen is you're deving all the apps in Chrome or in Edge or in Firefox, and sounds start to happen. And that's great. And then you're really proud, so you run to the nearest person next to you and pull out your phone and go to show them the same example, and nothing comes out of your iPhone. Why? Safari. So it does take what in every other browser is an optional argument, but in this case it's a non-optional argument of how many milliseconds from now would you like to start hearing the sound? Now. I want to hear it now. So you have to pass in 0 if you would like it to work in Safari or mobile Safari. Okay, so here's mistake number 1, and this is a mistake I personally made, is you start playing sound, and you are wearing headphones, and it's incredibly high-pitched. And you want to cry. So what you normally do in that case is you you crawl up back onto your desk and hit Command W or Control W to close the window. But let's say we want to do that programmatically. We want to stop playing the sound. Lucky guess, anyone? All right, this is good. It's all downhill from here, though. Okay, so we want to start playing the sound again. That doesn't work. Turns out that these oscillators are one-time use. You can start them, you can stop them, and then you got to toss them away. And if you need to disconnect them, otherwise they don't get garbage collected. So you can go ahead and disconnect the oscillator, and the garbage collector will eventually come around, pick it up, and everything will be good to go. All right. So we've got this destination. We hook it up. I don't want to manage, I don't want to manually manage these oscillators. That's not interesting to me. What I would rather do is put some things in the middle. Right? Because what I could do is I could just maybe have something that controls the volume, and I can turn that down, and I can turn it up, and everything is great in the world. So that's good, because we actually have other nodes other than just oscillators. We have this one called a gain node. And 0, it takes all the signal, and it flattens that sound wave so that there's no sound. At 1, it doesn't do anything. And from there, you can get all sorts of electric distortion. But we're going to treat it as 0 is off, 1 is normal. That seems like a way to implement my own ability to start and stop oscillators, right? Creating a gain node, you create a gain node. And then what we want to do is we have our oscillator. We're going to hook that up to the gain node. we're going to hook the gain node up to the destination. And so here we start with first connecting it to the gain node. Got a little ahead of myself. Then we take the gain node and we hook that up to the destination. So now we have something in the middle where we can adjust the volume. So now we can kind of effectively turn it off and turn it on by taking that knob, turning it down to 0, turning it back up to 10 or 11 if you want. You'll get a little distortion there. But we can turn that off and on, effectively like giving us the ability that we never had with the built-in API. So now this is what it could look like. We can start it immediately, and then you turn it to 1. It's playing. You turn it to 0. It sounds like it's off. It's really still going. Don't tell anyone, but it's fine. The other thing we might want to do with one of these is change the pitch. Out of the box, they come at 440, which is, for my delicate ears, a little too high. So we can adjust different values on these oscillators. So we can, for instance, change the frequency value to 220 or any number that makes you really happy. And we can also change the shape of the waveform, right? So by default, you get this fun sine wave. You could also make square waves. They look like squares. Triangle waves look like triangles. Sawtooth waves look like sawtooth. We'll actually listen to all of these in a second and figure out how they sound different. But changing those types, you change it to the type you would like. You can also create, if you want to get all mathematical here, you can actually create a function that actually shapes the waveform in some other way that you want. But that is beyond the scope of what we're going to do today. We're going to take one of these out of the box. So let's go ahead and experience each of these. The most dangerous part of any talk is going from not mirror mode to mirror mode and hoping that it works. All right. So I've got the slider, which is the volume right now. That's a gain node. I can turn it up and down. And I can adjust the frequency, and I can change the waveform. So let's start at 220. So sine waves are nice. They sound good. They're calming and pleasing, unless I let it go for another 15 more seconds, and then you're all going to go slowly insane. Square waves, not so great. Sawtooth, mediocre. Triangle, okay. You can see as we start to rise, we start to raise the frequency, the pitch goes up. Cool. So we can now make sounds in the browser. That's pretty neat. Stop that. Spoiler alert there. Avert your eyes. Okay, back to the presentation. So we can now make sound. Sound is necessary but not sufficient for making music. Yes, I made sounds. It'd be hard-pressed to assume that it was music, right? Not so great. All right, so let's get into very light level. When I found out that I wasn't very good at playing guitar, I was like, I'm going to learn music theory. To the point where I kept trying to take the entrance exam for the major in college. They wouldn't let me in. But this is what I got. This is what I got covered in that small time period. So it turns out that 440 is what we call A4, the fourth octave of A. If you were to double that to 880, you'd get an A note 1 octave higher. And if you were to halve that, you would get an A note 1 octave lower. All of the other notes find themselves somewhere in the middle there, right? We kind of just break it, and it just happens to be a thing that we do in Western music that we decided that these were the 12 parts, right? And there's crazy stuff that happens, right? Some of that, if you take a string, on a guitar, a stringed instrument, and you play the different harmonics, by putting your finger in the middle, you'd actually get the fifth there, and you get the third at the quarters. And there's some reasons why we got some of those points in there, but the rest of it is somewhat arbitrary. Different cultures have different semitones in the middle. And so we can see that if A at 440 is, if A4 is 440, A5 is 880, then you can just basically divide by 12 and get all the other steps in the middle. And that will work, right? But it only works some of the time. It only works in this case, in the key of A. If, for instance, we started at C and tried to do the same thing, you can see that they don't line up. And this is why you get you can buy a whole set of harmonicas, right? You get a harmonica in G and a harmonica in C. You can be a harmonica person, right? And have a whole kit of them. So as I was starting to play around with this stuff, I'm like, okay, you know what I'm going to do? I'm going to write an algorithm, because I know how to do that. And it's going to figure out how to do this for the right key and all this stuff. And that's very worthwhile, but like this was also, I was doing this for fun. We're getting very close to the I'm not doing this anymore, and I'll see a shiny object and do something else. And I realized that this is a solved problem, right? We solved this on all sorts of instruments. We solved this on pianos, right? I don't get a piano in the key of G. I get a piano, and then I don't play it. I don't buy a guitar in the key of G. Like, we basically figured out a good compromise amongst all of the keys. So what I did was I basically figured out what a piano does at all of these different points and decided that I never wanted to do that again. So I made a library that you can use, and we'll just use it because it basically creates an abstraction around a lot of this working with different intervals and figuring out what key you're in and moving up a fifth and down, stuff along those lines. And so you can use it today. And so the way it works is I can say new note, and I say A sharp 4, and it will know the frequency. I can also get the letter of it, the modifier, the octave, the signature, what key it would have been on the piano, on a normal piano. The cool other thing that I could do is I can never think about the given moving to the different values on a piano. If I say up an octave, it will give me that an octave up. If I say up a fifth, it will do that the same way. Cool. All right, so now we know how to we know enough musical theory to be dangerous. So let's see exactly how that might work. We're going to kind of recreate the piano in this case. This is our second little demo. All right, playing with fire, round 2. So here, I can hover over the keys. Or I can play I have a map to the different keys of the keyboard. Cool. And back we go. Scary every time. All right, so how does this work? It actually works a little bit the way that a normal synthesizer works. In a synthesizer, you might have 1 to 3 oscillators in most of your vintage synthesizers. And so you can play, in those cases, 1 to 3 notes. And depending on which of those are, the oscillators get set to different values, and they make the sounds. I have a MacBook with 8 gigs of RAM, so I just decided that everyone gets an oscillator. You get an oscillator, I'm not playing this shuffle oscillators around. I'm a front-end developer, I just use resources willy-nilly, it's fine. All right, so how does this work? User touches a key that emits a key down event. I listen for those key down events, and each one of those, I have a map for each one of those keys, and the different number of the key maps to some note, C3, A sharp 4, whatever. And then I gave myself a little abstraction here to figure out what note that should be. And we'll take a look at this code. Cool, so I start out with no oscillators whatsoever. This is just an object that's going to hold all my oscillators, but I'm lazy, and I don't make them all in advance. I'll make them as I need them. So whenever a given note comes in, I'll figure out, OK, what is the frequency of that note? And I'll use that little library that I showed you before, because I don't want to think about these things anymore. If I don't have that in that object, we'll go ahead and make it, and then give me back that oscillator that I made. So this is how we'll lazily make them. Cool, so neat. New oscillator, what is that? Good question. Thank you for asking. So we have an oscillator. And basically, it just abstracts. Remember all that craziness I did in the beginning where I had to create an oscillator and a gain node, and then I had to set the frequency of the oscillator, and we'll set the volume to 0 to begin with, and then I have to connect them all together, and I have to start the oscillator. That's cool. I don't ever want to do it. Right? And so this is an abstraction. If I say new oscillator, it will make the oscillator, make the gain node, hook them together, set the volume to 0, set the frequency to the right thing, and then I'll give myself a start and stop that'll just turn the volume on and off. So now I get the API that I wish I had with the oscillator to begin with. Abstractions are wonderful. This one has cost. Cool. So with key down event, we'll go ahead, find the right oscillator, and we'll start it. And then ideally, at one point, a user will take their finger off, and we will stop the oscillator, right? And that's basically how this entire example works. So all of a sudden, they hit the first key. we go ahead and we find that oscillator and its gain node, we turn it up. When the finger comes off, we turn it down. Neat. And that's cool, so we start out making sounds, and that's fine. Then we went one step further, and we created a musical instrument that already exists. Neat. But in the same way that someone put a synthesizer in a web browser, the inverse is also true. Somebody put a web browser in your synthesizer, right? Which means you can do web browser things as well as make music in the web browser. Do not tell anyone I told you that. And there's all sorts of different APIs that we have access to. For instance, we have the GetUserMedia API, where we can use the webcam and stuff along those lines, right? Wouldn't it be cool if we could somehow mix the ability to like get information from the user and also try to make, and this will be stretching the music part when you see it, but make music with that information. Are you all familiar with the idea of like a theremin? It's like those spooky like UFO sounds like in like old movies. What we're going to do is we're going to make a theremin with our face. I have a lot of these hats. That's true. All right, let's check it out. And here we go again. All right, there's my face. As you can see, we got some face tracking software here. And we got an X and a Y coordinate there and a height and a width. And you can see that that's going to translate to frequency and gain. So let's try it out. Let's turn it on. Get further away, gets quiet, get all up in his face. There's a few problems with this. One is when you're wearing headphones and your family walks in the door as you're trying to practice and see if it works. It raises a lot of questions about your mental sanity. All right, I'm done. Okay, how does this one work? Well, first of all, as any good JavaScript engineer, you start out just stealing some face tracking library. Done. Hard part's done at this point. It wasn't like node friendly, so I did have to like, or like maybe something, I did have to like copy and paste the file because the npm bundle didn't work. So I did open a pull request. All right, so the face tracking software like emits this big old object of like stuff, right? Is trusted. That seems important. The only two I really care about for this demo are height, which is like how big is the face, right? And that's basically a proxy for how far or close I am, not like is my head big. And then the x-axis, which is the like left, right. And so basically what I do is I pull those two objects off of the event, and then I do like some like tomfoolery with magic numbers to get it to like where it makes some amount of like where it doesn't sound awful, like either too low or too high. That's what this 1.5 minus or plus 220 means, because the x and y could be 0 to the width of the canvas, which is not going to, it's going to give me like very low tones that I can't hear. So we'll multiply it a little bit, and we'll start at 220, because in my experiments of splitting my eardrums open, that's a good place to start, right? Like if nothing else, 220, you're not going to hurt yourself. So we'll start there, and we'll figure out those, and then all we need to do is then we set the frequency based on x, and we'll set the gain based on the height of my face. And like, could you use width? Probably, yeah. And all we do is when the face tracking software fires a face tracking event, we simply update the oscillator, right? We update the frequency and the gain nodes. All right, neat. One of the other cool things about the web is that it is this like document viewer that we did happen to turn into the world's largest distributed system. So wouldn't it be cool if we could like do stuff where we can make music together, right? Ideally have a server with some WebSockets and be able to push out changes. So let's take a look at what that might look like. So here I have a little step sequencer. I can go put in some notes, like root, fifth, Oh no. So, I got a little carried away in those early ones. Just feeling too confident. Right? Adam, you got this? And ideally, anyone else could also connect and put in some other, and anyone can actually, you can actually play along with me. And you can see as other people begin to put stuff in, it's playing a mix of all of them together. And this is why we can't have nice things. And so you can see all of the different, all the other patterns from other users that are connected. You can all keep doing this. I'm going to mute it. I'm at work right now. All right. And so when a user touches one of these boxes, we send it out over WebSockets to a node server. That node server then takes that pattern and pushes it out to all of the other connected browsers. Each one goes ahead, so you get your pattern plus all of the other patterns that are currently being played by the other users, and as it steps through each one, it will go ahead and play the combined pattern of all of them. Cool. So we've made a bunch of musical instruments with software, right? But we can also use the software we're making to create new musical instruments with hardware, right? So we can hook up to a library like Johnny5, get some Arduinos, and be able to wire everything up. So you can actually make a Nintendo Power Glove that plays music as you touch your fingers together or something like that. The world is your oyster on this one. You can do whatever you want. I guess I have a demo for that. Come on. So it's a little simple demo. So this is a little, it's just 4 buttons and a potentiometer, which I can't believe I said correctly, where we can theoretically send WebSocket. Johnny5 listens for those buttons, right? And this is the diagram of it. So Johnny5 hears that someone touched a button on the Arduino. It will then go ahead and send a WebSocket request out to the browser. And all we'll do in this case is we'll say, well, we have 4 buttons. In this exact case, we'll say that the root note, the major third, the minor third, and the perfect fifth. That I can make major chords and minor chords. Right? This is deliberately simple. When it comes time, every time we get a button coming in, we'll say when the button comes down, we'll figure out which one of those intervals should be turned on. When the button press comes up, it's very like the synthesizer we built in the second example, right? When stuff goes down, we start playing the sound. When stuff comes up, we stop playing it. And the potentiometer will change the root note. So now we can move up and down, and we can play along on the Watchtower or something along those lines, or a Blink-182 song. All right, so this is what it's going to look like. Final demo. Can he remember to mirror the screen? Yes. So here it is. I can. Turn the potentiometer. Make it a sad little minor chord. If you thought live coding was hard, try to live Arduino music. It's an entirely different skill set that, in case you haven't figured out, I do not possess. But yeah, so we can actually create new instruments, physical instruments, and then use the web. You can mix in the idea of having collaboration through Essential Server or any of the other APIs. We'll take a look at a few more of those in a second. Cool. All right. So let's bring it home. So music is, as I'm told, pretty awesome. The web, also pretty awesome. Putting them together opens this whole new range of creative fun that you can have, right? And it doesn't have to be these super sophisticated things. It can be these very simple ideas you can play around with. I think that having some creative programming in your life helps you to learn new skills and try out new things without having to worry about legacy code and stuff along those lines. There's a lot of other APIs you can use. The browser has a game controller API. There's the device orientation. There's a gyroscope in a lot of mobile devices. There's WebRTC in other ways. You can have a multiple face theremin. So all these examples are on GitHub. They are right here. And I thank you all very, very, very much.